All right, good morning, everybody, and welcome to week 3. We are now officially underway with our fall semester. The schedules are frozen, from what I understand. Laptops are in play come the latter part of the week, we're hoping for. At least that's the schedule that I'm now being told. And again, in the meantime, like we hinted to last Friday, we're going to kind of like drag the Solid Professor and Inventor introduction to the back end of the week in the hopes of allowing a little time for everybody to get set up in Inventor. Now, some of you have asked for transcripts, and that's great. Just remember we're running version 2020, and keep those requests coming. I mean, because again, the sooner you get up and running, the better, as we all know. But for the here and the now, what I want to do is I want to introduce methods of manufacturing as a part of the curriculum that wouldn't normally show up until a little bit later, but we're going to move it up to the start of this week just for sake of the fact that we're running behind on our software updates. So in any event, I'll go ahead and get started. I'm in a shared view right now where you're looking at your class, or Engineering 2 is looking at their class. Now, what you're going to want to do in the meantime is you're going to want to go to the dashboard, or actually I'm going to go to modules, and you're going to scroll down and you're going to see week 3 has now been populated with defining manufacturing processes along with the review, read, and complete section. Now, the defining manufacturing processes tab is just an overview of what we're going to work on this week in terms of wrapping this section up. You're going to review the lecture today that will be recorded by the time we meet a little bit later. There's a short little metal removal conventional slideshow, and then there's going to be the requirements that meet the Google Doc of all the processes to be defined and illustrated, much like the assignment you just wrapped up on engineering roles and design processes. Those will include metal removal, like we just hit on, plastic, sheet metal, finishing processes, and so forth. What today's going to accomplish is it's going to introduce you to a couple of websites that you'll be able to pull all that information from, sources that I'm quite familiar with from my past working experience. So again, to go back to modules and scroll down, you'll see week 3 review underneath defining manufacturing processes. Again, that's going to be the video that will be uploaded and posted after this is officially recorded. You're going to see week 3 read, which is the slideshow that we're going to go through in a moment. And then you're going to see the complete, which is basically a doc similar to that of what you had last week to go through and define all the terms on. And that's what today is for, all right? To allow you to cut to the chase. Those of you that are in the Zoom meeting will probably double down on this, but no matter. The slideshow. If you look at it, and again, this is bare bones. Some of you have had me before in drafting one where we actually got on the machine and we introduced ourselves to a little bit of these processes, but and some of you have had this experience in your own manufacturing environment at home. But these are the basics: drilling, boring, reaming, and the metal removal operations as defined by the graphics, as you see here. A little bit of definition on what it is. Now again, you may not be getting involved per se in the detail when you define your processes, but this is a very important slideshow because what it does is it, again, goes real bare bones into the differences between these different metal removing operations. Drilling is more than anything else a roughing out process that starts from scratch and placing a hole into some type of fabrication or metal raw material or wood. It can be done by turning, and it can be done by milling machines, and there are examples included here. Boring is basically taking a drilled hole and opening it up to an additional amount in way of giving you an improved finish as well as a more accurate size. Reaming will accomplish the same thing with even less metal removal. And then counterboring will basically place a concentric inline, larger diameter on top of a through diameter for sake of, more often than not, burying a head bolt into the surface, so the surface is clear. And there's a couple of examples of each. And countersinking similarly, only now you're talking about a flathead screw as opposed to a cap head screw. And there's some examples there of a wood operation and different angles of the countersunk head. And then finally tapping, which allows you to place threads for a screw to actually thread into a plate as opposed to be dropped in for clearance. Just wanted to show you that. This is the other attachment that illustrates the processes that we're going to cover in a moment. Now, when you're dealing with manufacturing processes, you categorize them by either metal removal, in the machining methods that we just described, but there are other methods that you can form metal or process metal in a manufacturing facility, and those include the following: castings, welding, forging, stampings. And there are many examples that apply in the automotive, medical industry, and others. When you're dealing with plastics, you're dealing with extrusions and blow molding and so forth. And then finally, you've got finishing operations that cross over into both realms, but primarily are metal-based operations. And I'm going to show you a couple websites where you can access all this information with some comfort without having to mine the whole internet. And then this first page is all Engineering 2. All right. Engineering 3 cuts to the chase, and they have to, Engineering 2 is optional, go into a little bit more advanced research to not only capture automation in the way of robotic and CNC manufacturing methods, but also what I'd like you to do is, and this isn't even current by today's standard, 3D printing of alloyed materials, that's been going on for a while, but new and emerging technologies, that may be featuring, artificial intelligence in the manufacturing realm. This is cutting edge, and it's evolving, each and every month that passes by. And then this section basically includes the criteria from which you're going to put together your PowerPoint. All right. Again, very similar to last week. Now, a couple of websites I wanted to turn you on to. One, Orchid Orthopedic Solutions. This is a company or a flagship that I used to work for once upon a time. Orchid Orthopedics is basically one-stop shopping supply chain to the medical device community. All right. It's a company that I worked for a number of years out of the forging facility in Holt, Michigan. And if you click on the relevant facilities, or if you click on the process, which in this case under manufacturing is where we're you can peruse this website to your heart's content, but we're primarily looking at manufacturing operations. So as you can see, they coat, they forge, they cast, they assemble, and they machine. And if you click on any of these links, you're going to find relevant information and pictures to what it is that you're looking to accomplish here with your slideshow. And these are all items that you might have even seen in the classroom here. This is the facility that I spent the majority of my time with while with Orchid. But I've also worked with other companies in Arcadia, California, as well as the Orchid Detroit facility that's not listed here, but listed under machining, I believe. But anyways, peruse this and give me your impressions. I mean, this is a company that's near and dear to heart. I'd still be working for them if I didn't get the itch to, move into the OEM realm. And they're quite impressive, growing over the years, and they pretty much are an overall umbrella of institutions that can address instrumentation and implants from a variety of manufacturing methods. Another great site to hit is Cape Fear Community College. Obviously, they are near and dear to our heart, and they offer to go beyond the medical device industry. They offer baseline training in not only computer integrated machining that directly ties to our project work this week, but also welding technology, which is captured in our module list, bolt manufacturing and service, which may not be, but is indirectly related, and then automotive systems technology. Pull from these sources because you're going to see, not only excellent graphics that describe specific operations that will tie into your project work this week, but also, maybe turn you on to some programs of study that you weren't familiar with going in. Additionally, you've got, on the plastic side of things, you've got Cape Fear Mold and Tool, who we have worked with before. They are more of a small level plastic injection mold shop where they can work with components like smaller in nature that fit engine work and so forth. The Wilmington Machinery Company is much larger pallet-based systems, and they put out the machinery that produces large-scale plastic injection molded parts. And you can learn a lot from that particular site. So Wilmington Machinery, as well as Cape Fear Tool Mold, local facilities that we've worked with, on both large and small-scale plastic work, which again falls into the mix here. And then lastly, and these are all keyword searches, I'm not going to get into the weeds of giving you URLs, but lastly, our own site, my site, which is the home site on the faculty page. What you're going to see is under the gallery link, you're going to see some images, yes, of our Toys for Tots efforts, Chick-fil-A Club, and our showcases, as well as your own images from past accomplishments, but you're going to see some machining illustrated in here too. So these are sources that will help you out. Again, Orchid Orthopedic is probably your most far-reaching website of interest insofar as gaining some familiarity in the casting, forging, and really machining operations that are available in our industry. And I just want you to have some fun with this. This is something that I think basically is an extension of all things design, so it makes no difference whether you're in the mechanical class like you are now with Engineering 2-3, or heck, even the Revit class with Architecture 2-3. You have to look at the next step insofar as how this is going to lead to a career, and I can assure you that all things design lead to some form of fabrication, whether you're building homes, structures, commercial, residential, or in this case, fabricating products for either the medical or automotive or far-reaching industries across the world. There's a lot of opportunity here to not only accomplish our goals of defining these processes, but also for your own sake, maybe starting to further define what it is that interests you stemming from our work last week. All right? So, again, if you have any questions on this, give me a shout. I really want to spend some time with this. And again, once this is wrapped up, start to get into the solid professor work and throw any questions my way concerning that as well. I hope you all have a great week and enjoy what's now a semester that's fully engaged and underway, and I'll keep you updated on any new developments as the week plays out. Thanks, everybody, and we'll talk soon. Bye for now.